Hello, welcome back. I got a break and upload a video. It's not supposed to because this is damage. I'm uploading the video, but let's continue reading. So it's 12:30. So I don't like this lamp on when I'm reading. I'll take it off. I need a minute to go to my bed. Then I will make some hot food later in like 4 hours. 4 or 5 hours. Make fried eggs with rice and ketchup. No, I like to learning something new. It's why I do this, because I have to sit home alone in my apartment the rest of my life maybe. Because I don't have any money for anything. I have a low pension. I don't have money to do anything, travel or buy expensive stuff. But we can read a lot of time to reading. But it doesn't cost any money to read.
Tesla's AC dynamo electric machine, AC electric generator, in an 1888 U.S. patent 390,721 proposed to match the working frequency of Tesla's motor, but they soon found that it would not work for streetcars, since Tesla's induction motor could run only at a constant speed. They ended up using a DC traction motor instead. 77, 78. Market turmoil. Tesla's demonstration of his induction motor and Westinghouse subsequent licensing of the patent, both in 1888, came at the time of extreme competition between electric companies. 79, 80. The three big firms, Westinghouse, Edison, and Thomson Houston Electric Company, were trying to grow in a capital-intensive business while financially undercutting each other. There was even a war of currents propaganda campaign going on, with Edison Electric claiming their direct current system was better and safer than the Westinghouse alternating current system, and Thomson Houston sometimes siding with Edison. 81, 82. Competing in this market meant Westinghouse would not have the cash or engineering resources to develop Tesla's motor and the related polyphase system right away. 83. 2 years after signing the Tesla contract, Westinghouse Electric was in trouble. The near collapse of Barings Bank in London triggered the financial panic of 1890, causing investors to call in their loans to Westinghouse Electric. 84. The sudden cash shortage forced the company to refinance its debts. The new lenders demanded that Westinghouse cut back on what looked like excessive spending on acquisition of other companies, research, and patents, including the promoter royalty in the Tesla contract. 85, 86. At that point, the Tesla induction motor had been unsuccessful and was stuck in development. 83, 84. Westinghouse was paying a $15,000 guaranteed royalty. 87. Even though operating examples of the motor were rare and polyphase power systems needed to run it was even rarer. 69, 84. In early 1891, George Westinghouse explained his financial difficulties to Tesla in stark terms, saying that, if he did not meet the demands of his lenders, he would no longer be in control of Westinghouse Electric, and Tesla would have to deal with the bankers to try to collect future royalties. 88. The advantages of having Westinghouse continue to champion the motor probably seemed obvious to Tesla, and he agreed to release the company from the royalty payment clause in the contract. 88, 89, 6. Years later, Westinghouse purchased Tesla's patent for a lump sum payment of $216,000 as part of a patent sharing agreement signed with General Electric, a company created from the 1892 merger of Edison and Thomson Houston. 90, 91, 92, New York Laboratories. Mark Twain in Tesla's lab, 1894. Mark Twain in Tesla's South Fifth Avenue laboratory, 1894. The money Tesla made from licensing his AC patents made him independently wealthy and gave him the time and funds to pursue his own interests. 93. In 1889, Tesla moved out of the Liberty Street Sharp Peck and Brown had rented and for the next dozen years worked out of a series of workshop/laboratory spaces in Manhattan. These included a lab at 175 Grand Street, 1889-1892, the fourth floor of 3335 South Fifth Avenue, 1892-1895, and 6th and 7th floors of 46 and 48 East Houston Street, 1895-1902. 94, 95. Tesla and his hired staff conducted some of his most significant work in these workshops. Tesla Coil. In the summer of 1889, Tesla traveled to the 1889 Exposition Universelle in Paris and learned of Heinrich Hertz's 1888 experiments that proved the existence of electromagnetic radiation, including radiowaves. 96. Tesla found this new discovery refreshing and decided to explore it more fully. In repeating and then expanding on these experiments, Tesla tried powering a Ruhmkorff coil with a high-speed alternator he had been developing as part of an improved arc lighting system, but found that the high-frequency current overheated the iron core and melted the insulation between the primary and secondary windings in the coil. To fix this problem, Tesla came up with his oscillating transformer, with an air gap instead of insulating material between the primary and secondary windings and an iron core that could be moved to different positions in or out of the coil. 97, later called the Tesla coil, it would be used to produce high voltage, low current, high frequency alternating current electricity. 98. He would use this resonant transformer circuit in his later wireless power work. 99, 100, citizenship. On the 30th of July, 1891, aged 35, Tesla became a naturalized citizen of the United States. 101, 102, in the same year, he patented his Tesla coil. 103, wireless lighting. Tesla demonstrating wireless lighting via electrostatic induction during an 1891 lecture at Columbia College via two long Geissler tubes, Simultonian tubes, in his hands. After 1890, Tesla experimented with transmitting power via inductive and capacitive coupling using high AC voltages generated with his Tesla coil. 104. He attempted to develop a wireless lighting system based on near-field inductive and capacitive coupling and conducted a series of public demonstrations where he lit Geissler tubes and even incandescent light bulbs from across a stage. 105. He spent most of the decade working on variations of this new form of lighting with the help of various investors, but none of the ventures succeeded in making a commercial product out of his findings. 106. In 1893 at St. Louis, Missouri, the Franklin Institute in Philadelphia, Pennsylvania and the National Electric Light Association, Tesla told onlookers that he was sure a system like his could eventually conduct intelligible signals or perhaps even power to any distance without the use of wires by conducting it through the earth. 107, 108. Tesla served as a vice president of the American Institute of Electrical Engineers from 1892 to 1894. Forerunner of the modern-day IEE, along with the Institute of Radio Engineers. 109. Polyphase system and the Columbian Exposition. A Westinghouse display of the Tesla polyphase system at Chicago's 1893 Columbian Exposition. By the beginning of 1893, Westinghouse engineer Charles F. Scott and then Benjamin G. Lamb had made progress on an efficient version of Tesla's induction motor. Lamb found a way to make a polyphase system it would need compatible with older single-phase AC and DC systems by developing a rotary converter. 110. Westinghouse Electric now had a way to provide electricity to all potential customers and started branding their polyphase AC system as the Tesla polyphase system. They believed that Tesla's patents gave them patent priority over other polyphase AC systems. 111. Westinghouse Electric asked Tesla to participate in the 1893 World's Columbian Exposition in Chicago, where the company had a large space in the electricity building devoted to electrical exhibits. Westinghouse Electric won the bid to light the exposition with alternating current, and it was a key event in the history of AIC power, as the company demonstrated to the American public the safety, reliability, and efficiency of an alternating current system that was polyphase and could also supply other AC and DC exhibits at the fair. 112, 113, 114. A special exhibit space was set up to display various forms and models of Tesla's induction motor. The rotating magnetic field that drove them was explained through a series of demonstrations, including an egg of Columbus that used the two-phase coil found in an induction motor to spin a copper egg, making it stand an end. 115. Tesla visited the fair for a week during its 6-month run to attend the International Electrical Congress and put on a series of demonstrations at the Westinghouse exhibit. 116. 117. A specially darkened room had been set up where Tesla showed his wireless lighting system. Using a demonstration he had previously performed throughout America and Europe, winking sad smiley. 118. These included using high voltage, high frequency alternating current to light wireless gas discharge lamps. 119. An observer noted within the room were suspended two hard rubber plates covered with tin foil. These were about 15 feet apart and served as terminals of the wires leading from the transformers. When the current was turned on, the lamps or tubes, which had no wires connected to them but lay on a table between the suspended plates, or which might be held in the hand in almost any part of the room, were made luminous. These were the same experiments and the same apparatus shown by Tesla in London about 2 years previous, where they produced sonic wonder and astonishment. 120. Steam-powered oscillating generator. During his presentation at the International Electrical Congress in the Columbian Exposition Agriculture Hall, Tesla introduced his steam-powered reciprocating electricity generator that he patented that year, something he thought was a better way to generate alternating current. 121. Steam was forced into the oscillator and rushed out through a series of ports, pushing a piston up and down that was attached to an armature. The magnetic armature vibrated up and down at high speed, producing an alternating magnetic field. This induced alternating electric current in the wire coils located adjacent. It did away with the complicated parts of a steam engine forward/generator, but never caught on as a feasible engineering solution to generate electricity. 122, 123. Consulting on Niagara. In 1893, Edward Dean Adams, who headed the Niagara Falls Cataract Construction Company, saw Tesla's opinion on what system would be best to transmit power generated at the falls. Over several years there had been a series of proposals and open competitions on how best to do it. Among the systems proposed by several US and European companies were two-phase and three-phase AC, high-voltage DC and compressed air. Adams asked Tisla for information about the current state of all the competing systems. Tisla advised Adams that a two-phased system would be the most reliable and that there was a Westinghouse system to light incandescent bulbs using two-phase alternating current. The company awarded a contract to Westinghouse Electric for building a two-phase AC generating system at the Niagara Falls, based on Tisla's advice and Westinghouse's demonstration at the Columbian Exposition. At the same time, a further contract was awarded to General Electric to build the AC distribution system. 124